Ever wondered why we have leap years? Let's dive into the fascinating world of time. Time, an abstract concept, is measured in terms of the Earth's rotation around the sun, known as a solar year. But here's the twist. A solar year isn't exactly 365 days. Instead, it's closer to 365.24 days. A bit of a conundrum, wouldn't you say? So, how do we account for this extra time? Enter the concept of leap years. A leap year, in the simplest of terms, is a year that is exactly divisible by 4, except for end-of-century years, which must be divisible by 400. Now you might be asking yourself, why all the math? Well, it's all about keeping in sync with the sun. You see, our calendar year is based on the time it takes Earth to orbit the sun, which is about 365.25 days. To adjust for the extra quarter, an additional day is added to the calendar every 4 years, making it a leap year. But here's the catch. That extra quarter day isn't exactly a quarter, it's actually about 11 minutes short. So if we add a full day every 4 years over time, we would end up with too many days. To correct this, a year that is evenly divisible by 100 is not a leap year, unless it's also divisible by 400. Let's take a look at some examples. The year 24 is divisible by 4, so it's a leap year. The year 1900, while divisible by 4 and 100, is not divisible by 400, so it's not a leap year. But the year 2000, divisible by 4, 100, and 400, is a leap year. This means that the year 2000 was a leap year, while 1900 was not. But who came up with this complex system of leap years, you might ask? Well, the answer takes us back to the time of Julius Caesar, in the year 45 BC. The Julian calendar, as it was known, introduced the concept of a leap year, adding an extra day every 4 years to compensate for the almost 6 extra hours it takes Earth to orbit the sun each year. However, this system wasn't quite perfect. It overcompensated by about 11 minutes each year, which might not sound like much, but over centuries those minutes added up. By the 16th century, the calendar was about 10 days out of sync with the solar year. Enter Pope Gregory XIII. In the year 1582, he introduced the Gregorian calendar, which we still use today. This new calendar fine-tuned the concept of a leap year. While it still added an extra day every 4 years, it made an exception. Years divisible by 100 would not be leap years, unless they were also divisible by 400. This subtle adjustment corrected the overcompensation of the Julian calendar, keeping our calendar in alignment with the solar year. So, thanks to Pope Gregory XIII and his astronomers, we have a calendar that keeps us pretty much in sync with our solar year. Now, let's dive into some fun facts about leap years. One of the most intriguing aspects of leap years is the traditions and superstitions associated with February 29th. In Ireland, for instance, it's considered lucky for women to propose marriage on this day, a tradition that dates back to the 5th century. In Greece, however, many consider it unlucky to marry in any leap year, not just on the 29th of February. Then, there are the leaplings or leapers, those special few born on February 29th. They technically celebrate their birthdays only once every 4 years, but don't feel too bad for them. They get to choose whether they age in real years or leap years. Some even enjoy the unique privilege of celebrating their sweet 16th birthday when they're actually 64. Interestingly, the chance of being born on a leap day is quite slim, about 1 in 1,461. That's because there are 1,461 days in 4 years, and only one of those days is February 29th. And here's another fun fact, the year 2000 was a leap year, but the year 1900 wasn't. That's because even though most leap years are divisible by 4, a year that is evenly divisible by 100 is not a leap year unless it's also divisible by 400. So, the next time February 29th rolls around, remember the fascinating history and science that make this extra day possible? See you in the next leap year.